सब्सक्राइब कीजिए ईएसए क्लासेस चैनल को और बेल आइकन दबाइए हमारे लेटेस्ट वीडियो सबसे पहले देखने के लिए।
Kinetic theory of gases, gas laws, Boyle's law, PV is equal to constant, Charles V by T is equal to constant, Gay-Lussac's law, P by T is equal to constant, Avogadro's law, at same temperature and pressure, equal volume means equal molecules, then Graham's law of diffusion, rate of diffusion is inversely proportional to root of density. Rate of diffusion is inversely proportional to root of density. Rate of diffusion is what? Volume per second. Volume diffused per second. Rate of diffusion is also inversely proportional to root of molecular weight. Dalton's law of partial pressure. Summation of all partial pressures is equal to total pressure. If we have 2 moles of hydrogen and 1 mole of helium in this compartment and total pressure is unknown. If I put only helium into the chamber, then pressure is 1 atmosphere. If I put only hydrogen into the chamber, then pressure is 2 atmosphere. Then total pressure is 2 plus 1, 3 atmosphere. Total pressure of the mixture, if helium and hydrogen are put together, then total pressure is 3 atmosphere. 1 atmosphere is partial pressure of helium, 2 atmosphere is partial pressure of hydrogen. Then ideal gas equation is PV is equal to nRT. It can be written as PV is equal to capital N Kb into T. Kb is Boltzmann's constant. N is number of molecules. This is R, 8.314 joule per mole per Kelvin. Kb is Boltzmann constant. It is 1.38 10 raised to minus 23 joule per Kelvin. Then R by Avogadro number is equal to Boltzmann's constant. Assumptions of kinetic theory of gas. Tiny particles are called molecules. Tiny gas particles are molecules. Molecules are perfectly rigid, elastic spheres of very small diameter. For same gas, all molecules are of same size, same shape, same mass. Volume of molecule too much less than volume of gas. Random motion, molecules are in random motion in all direction in all velocities. That is called molecular chaos. Collisions are elastic, molecule-wall collisions and molecule-molecule collision. No energy loss. Then free path. Free path is straight line, straight distance between two consecutive collisions, and between two consecutive collisions velocity is constant. Time of collision is very small compared to time required to travel free path. Then this is the formula for mean path, summation upon n. Mean velocity this. Mean square velocity this. C1, C2, C3 are velocities of particle number 1, particle number 2, particle number 3. Therefore mean square velocity is this, summation of square of all velocities divided by n. And root mean square is root of mean square velocity. Then derivation for pressure of a gas. Pressure of a gas and RMS velocity are related by this formula. Derivation is not useful for the CET or NEET purpose. Then Boyle's law can be derived from this formula. CRMS is equal to root 3p upon rho. CRMS is equal to root 3p upon rho. But CRMS is independent of pressure. It looks like CRMS is proportional to root of pressure, but it is not. CRMS is independent of pressure. CRMS is equal to root 3 PV upon m dash. It is also 3 RT upon m. M is molecular weight, T is temperature. It is 3 kT upon m. M is mass of one molecule, T is temperature in Kelvin, K Boltzmann constant. CRMS proportional to root of temperature, inversely proportional to root of molecular weight. CRMS upon C of sound is root 3 upon gamma. Then for moon, CRMS is greater than C escape. Therefore, moon has no atmosphere. All the air molecules on the moon have escaped gravitational field of moon because CRMS is greater than C escape. Kinetic energy of gas, P is equal to 1 by 3 m dash upon V, CRMS square. M dash by V is the density rho. So kinetic energy of total gas is this much, 3 by 2 PV. Kinetic energy per volume divided by volume, 3 by 2 P. Kinetic energy per mole, PV is equal to nRT. So instead of PV I have put nRT, but n number of moles is 1 per mole. So RT. Per molecule 3 by 2 kBT, and per mass 3 by 2 RT upon molecular weight. Then this is most probable speed, this is average speed. Then Maxwell's distribution. Maxwell's distribution gives velocity distribution of molecules of gas. All gas molecules do not have same velocity, but at constant temperature distribution of speed is constant. At constant temperature distribution of speed is constant. So this is the graph and V versus V. So this velocity is V1, this velocity is V2. If I want number of molecules in the gas between velocities V1 and V2, then I have to find out area of this strip. Area of this strip is equal to number of molecules having velocities between V1 and V2. Okay, so how to calculate this area? We can calculate this area by using these formulae, but these formulae are out of scope of our syllabus. Then degrees of freedom and law of equipartition energy. What is the law of equipartition energy? Total energy is equally distributed in all possible energy modes. Total energy is equally distributed in all possible energy modes, each having half kBT energy. So if atom is monoatomic, degree of freedom F is equal to 3a minus 1. 3a, A is number of atoms. So 3 into number of atoms 1 minus B is number of bonds. There are 0 bonds. Therefore this is equal to 3. So monoatomic molecule has 3 degrees of freedom. 3 degrees of freedom means what? It has 3 translational degrees of freedom. It can move in X, Y and Z direction. 3 translational degrees of freedom, and each degree of freedom has half kBT energy. So total energy of monoatomic molecule is 3 by 2 kBT. Then for a diatomic gas without vibrations, degrees of freedom is equal to 3 into A minus B. A is number of molecules, number of atoms 2 minus number of bonds 1. So this is 5. Degree of freedom is 5. So in each mode there is half kBT energy. So total energy of a molecule is 5 into half kBT. So 5 by 2 kBT. It has 3 translational modes and 2 rotational modes. Then with vibration, if vibration is considered, then there are 5 plus 1 vibrational mode, 6 degrees of freedom, and total energy is 5 into half kBT, 5 by 2 kBT, due to translational and rotational motion, and 1 vibrational Degree of freedom has energy kBt. One vibrational degree of freedom has kBt energy. So total energy becomes 7 by 2 kBt. For triatomic gas, degrees of freedom without vibration. For linear structure there are 7 degrees. For non-linear structure there are 6 degrees. Then specific heat capacities of gas. For monoatomic, energy of single molecule is 3 by 2 kBt, energy of one mole is 3 by 2 RT. So a derivative of this is Cv. Cv is 3 by 2 R and Cp is Cv plus R. So Cp becomes 5 by 2 R, Cp 5 by 2 R, Cv 3 by 2 R. So gamma is Cp by Cv 5 by 3. Then for diatomic gas without vibrations, energy per molecule is 5 by 2 kBt. Therefore energy per mole is 5 by 2 RT. Derivative is Cv. Cv is therefore 5 by 2 R. Cp is 7 by 2 R. Cp is Cv plus R. Gamma is 7 by 5. Then with vibration, energy per molecule is 7 by 2 kBt, energy per mole is 7 by 2 RT. So Cv 7 by 2 R, Cp is 9 by 2 R, gamma is 9 by 7. For polyatomic gas, 3 translational degrees of freedom, 3 rotational degrees of freedom, and there are F modes of vibration. So addition of this becomes U. Addition of this becomes not U, this becomes ET, energy of one molecule. So U is equal to 3 plus F RT. Therefore Cv becomes 3 plus F derivative R. Cp becomes 4 plus F R and gamma becomes 4 plus F upon 3 plus F. Then specific heat of solids. Solid molecule has no translational and rotational degrees of freedom. It can only vibrate in all directions, X, Y and Z. And each vibrational degree of freedom has kBt energy. Therefore it has, one molecule has energy 3 kBt. Therefore 1 mole has energy 3 RT and derivative of this is 3R. So 3R is specific heat of solid. Then Meyer's formula is Cp minus Cv is R. Cp is gamma R upon gamma minus 1 and Cv is R upon gamma minus 1. Cv R upon gamma minus 1, Cp gamma R upon gamma minus 1. Then solid C we saw 3R. For water, C is 9R by considering water as solid. There are 3 atoms in the water. 3 atoms have 3 vibrational modes, 3 modes, 3 modes, 3 modes. So 3RT, 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 total energy is 9RT and derivative is 9R. Actually C should be independent of temperature, but in reality it is dependent on temperature. Then tau. Tau is the time between 2 successive collisions. Its formula is 1 upon pi d square V into N. D is diameter of molecule. V is average speed. N is molecules per volume. And mean free path, formula for mean free path is this: 1 upon root 2 N pi d square. N, pi and d, their meanings are same as this one.